Well, starting with the level 3 questions. There are 8 equal resistances each R. 2 are connected in parallel and such 4 groups are connected in series. The total resistance you are asked to find out. Okay. Children, how many resistances are given? So, totally there are 8 resistances are given now. So, what is the value of each resistance? R. 2 are connected in parallel. Okay. So, 8 equal resistance if you consider 2. Resistance 1 and resistance 2 are connected parallel. Such 4 groups are connected. Out of 8 we have already used 2. R ohms and R ohms. Again 2 more are connected like that. R and R. How many such groups are formed? Totally 8, no? 4 groups are formed. So, again one more. So, space is not there. So, let me drop one more over here. Yeah, this is R and R. So, there are 8 equal resistance each of R 1, 2, 3, 4, 5, 6, 7, 8 and 2 are connected in parallel and such 4 groups are connected in series. These 4 groups are again connected in series. You are asked to find the total resistance. What is the total resistance, children? Let us solve it. These 2 are connected in parallel. What is the formula for parallel? If 2 resistances are connected in parallel, the formula for that is net resistance, equivalent resistance is equals to 1 by R plus 1 by R. This is equals to 2 by R. If 1 by R equivalent is equals to 2 by R, then R equivalent will be equals to R by 2. How much is that? R by 2. So, if we consider the equivalent resistance of this combined 2 resistors, then you will be getting something like this. Overall 2 resistance after combination, you are getting it as R by 2. R and R, R by 2. Here also R and R parallel means you are getting R by 2. There also R and R, R by 2. And the last one R and R, R by 2. So, for this R by 2, this value R by 2, this value R by 2 and this value R by 2. As all the 4 are now connected in series, the net resistance will be R in series will be R by 2 plus R by 2 plus R by 2 plus R by 2. So, further simplification gives the series resistance as R LCM is 2, common denominator, so LCM is 2. So, 2 upon numerator we have 4R. So, this after further simplification, so how much are we getting, children? This will be 2R. How much? 2R. Hence, the correct option must be 2R. That is, second option is true. Okay. So, 4 in series. Well, the next one, 1 ampere is equals to, we already solved this in some previous exercises, but still let us go through this. The value of 1 ampere is how many microamperes? Mu indicates your microamperes. So, we know that the 1 microampere is nothing but 10 power minus 6 amperes. 1 microamperes is equals to how much? 10 power minus 6 amperes. If I would like to find out 1 ampere, so may I write this as, for your understanding purpose, into 1 ampere, 10 power minus 6 into 1 amperes. Keeping this 1 ampere here and bringing this 10 power minus 6 the other side, we have 1 by 10 power minus 6 microamperes is the value of 1 ampere. So, this 10 power minus 6, if it is brought to numerator, then it will become 10 power 6. So, 10 power 6 microampere is equals to 1 ampere. Hence, the correct option must be first option, that is 10 power 6 microamperes. Okay. Well, now to the next question. How many electrons constitutes a current of 1 microamperes? So, what you are asked to find out, children? How many electrons constitutes a current of 1 microamperes? What is the formula for current, children? We know that I is equals to Q by T. Very beginning fundamentals we have discussed. So, I is equals to Q by T and the value of Q is equals to plus or minus NE. So, NA upon T. Hence, I can be written as number of electrons upon the time taken. Okay. And if T is taken as 1, if T is equals to 1, so in 1 second, how many electrons would have flowing through the conductor? Then the value of I must be is equals to N into E. Okay. I can be written as N into E whenever T is taken as 1 second. So, you are asked to find the value of N. Hence, N can be written as, N means the number of electrons, I upon E. So, how much is the current given? Current of 1 microamperes, current of 1 microamperes, I value is given. And E indicates the charge of electron whose value is equals to 1.6 into 10 power minus 19 coulomb. So, this write it in. So, microcoulomb in terms of amperes, it can be written as 10 power minus 6 amperes in SI system, and this is 1.6 into 10 power minus 19. So, the number of electrons here you can find it out. You may, so I just have removed the units, children, so that you will not confuse. Why? Because if you write the units, you also need to consider the value of time. Time is measured in seconds. As I have time, I considered as 1. The unit second will be missing, so that will be confusing. I simply ignored the units, just finding out the number of electrons. So, N is equals to 10 power minus 6 upon 1.6 into 10 power minus 19. If this 10 power minus 19 is brought upwards, then it will be becoming 10 power minus 6 into 10 power plus 19 upon 1.6. So, denominator how much you are left with? 1.6. So, this can be written as minus 6 and 10 power 19 is 10 power 13. So, 10 power 13. Here nothing is there, denominator 1.6. I would like to write it as 1 by 1.6 into 10 power 13. Nothing is there means I just would like to multiply with 1. So, 1 by 1.6 into 10 power 13. So, 110, let me introduce here. Then, to find out the value of N. So, how much is the, therefore, the value of N is equals to, out of 10 power 13, 110 I am taking, children. So, then it will be 10 upon 1.6 into, now you are left with only 10 power 12. If you divide 10 upon 1.6, you may get the value as 6.25. 10 divided by 1.6, you will be getting something like 6.25. And the leftover number is 10 power 12. So, how many electrons constitute a current of 1 microamperes? 6.25 into 10 power 12 electrons constitutes a current of 1 microamperes. Hence, the correct option is option B, that is 6.25 into 10 power 12 microamperes. Sorry, 10 power 12 number of electrons. And now, the next one, 25th, the law which gives a relation between the electric potential difference, okay, electric potential difference or simply potential difference indicated with the letter V, okay, and the electric current indicated with the I. So, what is the relation between V and I, children? V is equals to IR. So, who said this? This relation was obtained from Ohm's law. So, what does Ohm's law states? The potential difference across the two terminals is inversely proportional to the directly proportional to the current across the conductor. This is what they were saying. Okay, so this indicates your Ohm's law. So option C must be true. Over. Well, and now next question, the variable resistance is called, I told you we have fixed resistance and variable resistance. Variable resistance, I showed you the picture also in the previous classes. It will be having 3 terminals. There are the 2 terminals if you acts as a potential divider, and the middle connector, whatever is there, we can change its position such gradually, such that we can change the resistance. That is called as your rheostat. So rheostat itself has 2 names. One is the variable resistors, because the resistance can be changed. Okay, and another name is your rheostat. Hence the correct option is rheostat. Variable resistance is also called as your rheostat. Well, now the last question. An ammeter has 20 division. So how does an ammeter looks like, children? Something like this. An ammeter looks something like this, indicated with the letter A, and it has a pointer to indicate the readings, some A. Okay, and the pointer will be showing some particular value, say some 0.1, 0.2, some value it will be indicated. Ampere, A indicates your ammeter, and this measures the ammeter, ammeter generally measures the electric current passing through the circuit. So what it was given that this ammeter has totally 20 divisions marked from 0 to 2. In between 0 and 2, how many divisions are there, children? This is 5 divisions, 10 divisions, 15 divisions, totally 20 divisions are there between 0 and 2. Okay. The least count of the ammeter is, earlier we have solved for voltmeter, now here it was asking for ammeter. That's it. If 20 divisions indicate marking as 2, then what is the value of 1 division indicates? The value of 1 division must be equals to 2 by 20, and after simplification it will be nothing but 1 by 10. Hence the value of 1 division must be equals to 0.1 ampere. Hence the correct option must be option D, that is 0.1 amperes. So with this we have concluded with the worksheet number 3, level 1, 2 and 3 questions respectively. So the next class we shall move to the worksheet number 4. Until then, keep practicing and watch our videos. So